Here's a mind-blowing discovery that's forcing astronomers to completely rethink everything they thought they knew about how planets form. And it might finally explain why every planet in our solar system sits at a wonky angle. For decades, scientists have been puzzled by a fundamental question. Why don't the planets in our solar system orbit the sun in perfect alignment? Instead of spinning around our star like a well-organized cosmic carousel, each planet follows its own tilted path through space. Earth leans at a 7.25-degree angle relative to the sun's equator. Mars tilts at 5.65 degrees, and Jupiter sits askew at 5.51 degrees. But here's where it gets controversial. A groundbreaking new study suggests these planetary quirks might not be random accidents after all. Using the powerful ALMA telescope array, that's the Atacama Large Millimeter Submillimeter Array for those keeping track, an international team of researchers embarked on an ambitious mission called ExoALMA. Their goal? To peer deep into the cosmic nurseries where baby planets are born and see what secrets they might reveal about our own solar system's chaotic formation. What they discovered has sent shockwaves through the astronomical community. The research team, led by Andrew Winter from Queen Mary University of London, examined 15 planet-forming disks, those swirling clouds of gas and dust that surround young stars like cosmic construction sites. Using a clever technique that measures the Doppler shift of carbon monoxide gas, think of it like cosmic radar that can detect which way gas is moving, they made a startling observation. These supposedly perfect disk structures that we've imagined for so long, they're actually warped. And this is the part most people miss. The warping isn't just a minor imperfection. These disks can twist and bend by anywhere from half a degree to 2 full degrees, completely shattering our picture-perfect model of planetary formation. Our results suggest that protoplanetary disks are slightly warped, Winter explained, though his understated tone hardly captures the revolutionary nature of this finding. This would be quite a change in how we understand these objects and has many consequences for how planets form. For beginners trying to wrap their heads around this concept, imagine trying to spin a pizza dough perfectly flat, except cosmic forces keep nudging different edges, creating subtle ripples and waves across the surface. That's essentially what's happening in these planet-forming disks, but on a scale so massive it defies comprehension. The traditional textbook image of planetary formation depicts these disks as neat, orderly structures, perfectly flat toruses of material swirling around a central star like a cosmic record player. But this new evidence suggests that reality is far messier and more chaotic than anyone anticipated. The universe, it seems, doesn't follow our tidy expectations. But here's where the mystery deepens. What's causing these warps in the first place? Scientists have proposed several theories, each more intriguing than the last. Could invisible companion stars be lurking in these systems, their gravitational pull creating tidal forces that twist and contort the disks like cosmic taffy? Or perhaps the warping results from the chaotic dance of dust and gas particles, colliding and interacting in ways that create pockets of turbulence throughout the disk. The research reveals fascinating connections that hint at an even bigger picture. The rate at which material flows from the outer disk onto the growing central star appears directly linked to the characteristics of these warps. This suggests a dynamic relationship between the star's immediate surroundings and the outer regions where planets are taking shape. A cosmic feedback loop that could fundamentally alter how we understand solar system formation. Winter's team didn't stop at observations. Their computer simulations revealed that these warps might be responsible for the beautiful spiral patterns astronomers have photographed in some planet-forming disks. Even more remarkably, the warping could create temperature variations of up to 10 degrees Celsius across different sections of a single disk. Enough variation to dramatically influence which types of planets form where. And this is where the story becomes personally relevant to everyone on Earth. The degree of warping observed in these distant stellar nurseries matches almost perfectly with the orbital tilts we see in our own solar system. This isn't just a cosmic coincidence. It's potentially the smoking gun that explains why our planetary neighborhood looks the way it does. These modest alignments may be a common outcome of star and planet formation, Winter noted. Though this seemingly simple statement carries profound implications for our understanding of planetary systems throughout the galaxy. The discovery opens up entirely new avenues for theoretical research. Armed with knowledge about these disk warps, scientists can now input this crucial variable into their computer models of planet formation. This could revolutionize our understanding of how Earth and its neighboring worlds assembled themselves from cosmic dust billions of years ago. But here's the controversial question that's dividing the scientific community. If warped disks are the norm rather than the exception, what does this mean for our assumptions about potentially habitable planets around other stars? Could these warping effects actually be beneficial for creating diverse, complex planetary systems like our own? Or do they represent chaotic influences that make stable, Earth-like worlds less likely to form? The implications extend far beyond academic curiosity. If planetary formation is inherently more chaotic and unpredictable than we thought, it could reshape our estimates of how common habitable worlds might be in our galaxy. Some researchers argue this adds to the complexity and richness of planetary systems, while others worry it introduces too many variables to make reliable predictions about exoplanet characteristics. The research findings, published in the Astrophysical Journal Letters, represent just the beginning of what promises to be a fundamental shift in astronomical thinking. As more powerful telescopes come online and observation techniques improve, we'll likely discover even more surprises about how planetary systems form and evolve. So what do you think? Does this discovery make you more optimistic or more pessimistic about finding Earth-like worlds elsewhere in the universe? Are we looking at evidence that our solar system formed through beautifully orchestrated chaos? Or does this suggest that stable planetary systems like ours might be rarer than we hoped? The debate is just getting started, and astronomers are eager to hear how the broader scientific community and the public interprets these game-changing findings.